All right, so it's been a while since we broke down the full fiberglass installation process. We cover a lot of individual jobs on this channel, repairs, reglasses, and maintenance. But today, we're going start to finish. Every single step, nothing skipped. So let's go. Fiberglass can bond to a variety of substrates. We've done installs on concrete. We've worked with different spec materials depending on the builder, the project, different architects, different budgets, different build specs. All of that plays a role in what goes down first. That said, on our new construction installs, our default is AC plywood. The A face is smooth. There's no voids, there's no surface imperfections, there's no rough grains. It gives the fiberglass a clean, flat surface to bond to consistently. It's what we've standardized on because it works every time. The broader point is this: whatever substrate you're working with, it has to be solid. It has to be clean. It has to be something the fiberglass can bond to. Fiberglass is only as strong as what it's bonded to. Get the substrate wrong and nothing else matters. Once the plywood is down, the first thing we do is sand everything. And this is where a lot of the detail work happens before a single piece of fiberglass goes on. All of the sharp edges get rounded out. The post bases get rounded. If there are door openings, those get addressed here too. By the time we're ready to lay fiberglass, all those transitions are already prepped and rounded. After the sanding, all the voids get filled. Nail holes, seams between plywood sheets, any surface imperfections, all of it gets filled with GP fiber putty. Think of it like a Bondo specifically formulated for fiberglass applications. Now, here's the sequence that matters. You don't start in the field. You start at the edges. Every time. We work on the fascia, the sidewall transitions, the post bases, and any door openings first. All of this gets done before the field sees any fiberglass. For the edges, we use a 12-inch fiberglass mat roll, 1.5 ounce. The surface gets pre-wetted with catalyzed resin first. Then the mat goes on, gets fully saturated, and the air bubbles get rolled out immediately, working in 4 to 6 foot sections at a time. At the wall transition, there's actually a 2-layer detail. The first 12-inch piece goes against the wall, then a second piece, ripped from that same 12-inch roll down to about 6 inches, gets laid as a reinforcement right at transition from the field up to the wall. There's usually a chamfer strip at that transition point. Sometimes there isn't, but either way, that reinforcement layer is what creates a solid tie-in from the field surface up the wall. That's an important detail that you won't see once the job is done, and that's what keeps the transition from becoming weak over time. Same 2-layer principle on the posts. First piece wraps the post itself. Second piece reinforces the transition from the base of the post down to the field. That transition point is where stress concentrates, so the reinforcement layer is what protects it. For the drip edge, the entire 12-inch roll gets used across the full perimeter. The fascia face and the top of the field both get pre-wetted. Then, the mat gets laid across both surfaces at once. It bridges the edge, it gets fully saturated, and the air bubbles get rolled out. It's a clean, continuous edge from the field to the fascia. So with all the edges, transitions, post, door openings done, now the field gets glassed. As soon as a catalyst gets added to the resin, the clock starts because the resin is actively curing from that moment, so batching matters. You don't mix a massive batch and try to do everything at once, especially on detail work. Details take time, and that resin is not going to wait. Work in batches, size, so that you can actually complete before the resin kicks. On the field, the mat gets laid directly on the surface. There's no pre-wetting the field. The saturation happens after the mat is down. That's where the skill comes in. The person wetting out the field has to work the resin into the mat evenly and thoroughly across the entire surface. Not too little, not too much, and that second part matters. More resin is not better. Overly saturated fiberglass is actually weaker than properly saturated fiberglass. The resin and the mat work together at the right ratio. Too much resin, and you've compromised the lamination just as much as a dry spot would. So the wet out process on the field requires attention and experience. Full, even saturation across every inch of the mat with no dry spots and no flooding. Behind the person wetting is the person rolling the air bubbles. That person has to stay right on top of it. Once the air bubbles are out and the resin kicks, that's your final product. The mat and resin harden together as one. Now it cures when you leave it alone. The resin is cross-linking and hardening. Temperature affects it, humidity affects it, hot summer days, it moves fast. In cool fall weather, it kind of slows down, doesn't go as fast. Either way, don't walk on it, don't touch it, don't rush it. This is when the system is actually forming at the material chemical level. Same principle as concrete, in a way. You wouldn't walk on a freshly poured slab. The cure time isn't downtime, it's part of the process. So once it's cured, the surface is rough. The matte texture is still on it, and there are high spots. And before any gel coat goes on, we have to address all of that. So the full deck gets sanded down to a smooth, even surface. Any dings, any air bubbles that need to be opened up and filled, any imperfections, all that gets addressed at this stage. Same as the initial prep. You're creating the surface that everything else builds on. The entire deck gets mopped with acetone. This removes any oils, any contamination, anything that would prevent the gel coat from bonding properly. The gel coat needs a clean surface. The acetone mop is what guarantees that. Gel coat is catalyzed, same principle as the resin. The clock starts when the catalyst goes in, so you work in batches. So we start by cutting in all the edges. Brushwork around every transition, every post base, every wall, every door opening, anywhere the roller can't really reach gets done by hand first. Same reason a painter cuts in at the ceiling before rolling the wall. You cut in first and then you roll into it. The field coat blends right into that cut in line. Sometimes we cut the edges in and we don't paint the field right away. And there's a reason for that. If there's still construction happening on that deck, siding going up, roofing, anything that puts workers and materials on the surface, a freshly gel coated field is going to get damaged. And damage to finished gel coat means coming back to repaint. That costs the builder money and costs us time. So on active construction sites, we'll sometimes hold off on the field until everything above and around the deck is done, all the siding, the roof is complete, and there's no more traffic on the surface. Once everything is buttoned up, we come back. Give the deck another acetone mop if needed, and roll the field. Full gel coat across the entire surface. After 24 to 48 hours of cure time, the deck is fully done and ready to use. That's the full process. Do the substrate, you sand and prep, you fill the voids, do the edges and the transitions first, then you do the field. You let it cure, come back and sand, acetone mop, cutting the edges, and do the field gel coat. That's it. Every step in that order, every single time.